Hello everyone, myself Dr. Thrimurthulu, Professor in Department of CSC, MLR IT, and today's topic is genetic algorithm. I am going to cover today's video, and in that video, in this lecture, I am covering the what is genetic algorithm, what are the characteristics of genetic algorithm, what are the key components in that genetic algorithm, what are the requirements for the genetic algorithm, and reproduction process or crossover process, what it is in this case, and what are the general algorithm flow of the genetic algorithm, what are the advantages, disadvantages, and what are the applications of genetic algorithm. These are the topics I am going to cover now. And genetic algorithm introduction. So after scientists because disillusionized with classical and neoclassical attempts at modeling intelligence, they looked in other directions. So what are the other ways to find the goal? Two prominent fields arose in this case. Attempts at modeling intelligence, they looked in other directions. So two prominent field arises in this case. One is the connectionism, that is nothing but a neural networking or parallel processing, and evolutionary computing method. These two they are using that one. It is the later that it is easy deals with genetic algorithms are one of the best approach, genetic programming or genetic algorithms, to find the best path or to find the search algorithm, that is the one of the best search algorithm. So what is the genetic algorithm here? So genetic algorithm is a search technique used in computing to find true or approximate solutions to optimization and search problems purpose. Genetic algorithm is the one of the best approach. Genetic algorithms are categorized as global search heuristics based on the global search heuristics. Genetic algorithms are particular class of evolutionary algorithms that use techniques inspired by evolutionary biology, how the generation is going on, next generation. Based on that, this genetic algorithm also this same concept, biology concept, evolutionary biology concept, such as inheritance. It has inheritance feature, and mutations are the selection process, crossovers, like nothing but a production, also called as recombination process. So these are the genetic algorithm approach classes. Then, so what are the characteristics? Genetic algorithms are implemented as a computer simulation in which population of abstract presentations called chromosomes or genotype or genomes of a candidate solutions called individuals or creatures or phenotypes to an optimization problem evolves toward better solutions purpose. We are using the genetic algorithm computer simulation. We are using the genetic algorithm for population purpose, population counting or population identification purpose, males or females. Like this is the genetic algorithm is very much useful. Traditionally, solutions are represented in binary as strings of zeros and ones combination, but other encodings are also possible in this. The evaluation is usually starts from a population of randomly generated individuals and happens in its generations. Like this is continuous process, then next generations like this. In each generation, the fitness of every individual in the population is evaluated. Fitness factor, yeah, this is the one of the important factor. Multiple individuals are selected from the current population based on their fitness factor and modified, that is modified based on the recombined or possibly mutation to form a new population. So that is the each generation you are identifying based on their fitness factor and the recombination. So the new population is then used in the next iteration of the algorithm. And every time new population, new fitness factor, based on the fitness factor, you are identifying the next related thing. Commonly, the algorithm terminates when either a maximum number of generations has been produced or a satisfactory fitness level has been reached for the population. Then it is terminated. If the algorithm has terminated due to a maximum number of generations A satisfactory solution may or may not have been reached. So here, what are the key terms in genetic algorithm? Individual, any possible solution, that is population. Population means a group of individuals that you are called as a population. All the, in case of the nodes, individual node, or population, nothing but a group of nodes. Search space, you are searching all possible solutions to the problem. Chromosome, that is the one of the main blueprint for an individual, that is trait, possible aspect of an individual, nothing but a trait, nothing but a one of the feature, that is features. LLA, LLA, that is the possible settings of trait, black, blonde, like this, based on the feature. This is also another feature. Locus, the position of gene on the chromosome, where it is, the local point position of the chromosome. Genome, the collection of all chromosomes for an individual, that you are called as a genome. These are the key terms in genetic algorithm we are using. Then here one examples are there. Figure clearly it is. See here, this is the one genome, complete genome. This is the complete genome. In this genome, chromosomes are there. These are the chromosomes, related chromosome, next generation. What it is, if it is yellow, this is the next gene. Like this is next generation, next generation. Like this, it is the continuously you are evaluating the things. Suppose if you are taking this the one type of genotype from yellow to next generation, like this. So here genotype, particular set of genes in a genome. In this genome, particular sets are there. All these are the individuals, different fitness factors. Phenotype, physical characteristics of the genotype. Smart, beautiful, healthy. That is the one of the features it have based on. These are the examples, chromosomes. And so what are the requirements for the genetic algorithm? A typical genetic algorithm requires two things to be defined. One is genetic representation is important, representation of the solution domain. Representation of the solution domain, that is important. And the second, the fitness function to evaluate the solution domain. So these are the one is the genetic representation is important. Second one is the fitness function. A standard representation of the solution is an array of its array of other types and structures can be used essentially in the same way. The main property that makes these genetic representations convenient is that their parts are easily aligned due to their fixed size, the facilities, simple crossover operations, or reproduction operations. Variable length representations may also be used, but crossover implementation is more complex in these cases if it is the variable length. Tree-like representations are explored in genetic programming. So tree-based one by next generation, next root level, root to next branch level, again next sub-branch level, like this. The sub-branch nothing but a next generations, like that tree level. The fitness function is defined over the genetic representation and measures the quality of the represented solution. The fitness function is one of the important. The fitness function is always problem dependent, that depending on the what kind of problem that is. For instance, if the knapsack problem, we want to maximize the total value of objects that we can put in a knapsack of some fixed capacity. So a representation of a solution might be an array of bits where each bit represents a different object, and the value of bit, it may be either 0 or 1, represents whether or not the object is in the knapsack, whether it is in the knapsack it is present or not. So not every such representation is valid, as the size of the objects may exceed the capacity of the knapsack. The fitness of the solution is the sum of values of all objects in the knapsack if the representation is valid, or zero otherwise. In some problems, it is hard, even impossible, to define the fitness expression. In these cases, interactive genetic algorithm are used for that purpose. If it is the hard impossible to define the fitness function, those cases interactive genetic algorithms are used. So here GA requirements, suppose here bit string is there like this, bit string 0101 like this, and real numbers. These are the permutations of elements. List of rules are one or two or three like these rules are here defining program elements, genetic programming. What are the elements you have taken in that? And these are the based on the fitness function. Suppose every individuals have the fitness function is there. These are the fitness functions of the individuals. This based on the computations you are finding the ranking. So the second one is the first rank like this, nth is the second rank like this based on the fitness function. Which one is the best one? That you are keeping in a ranking. You are keeping as a rank. So every fitness function you are giving the ranking like that. And genetic algorithms, of it is the common type of genetic algorithm works like this. A population is created with a group of individuals created randomly. The individuals in the population are then evaluated. The evaluation function is provided by the programmer and gives the individuals a score based on how well they perform at the given task. Two individuals are then selected based on their fitness. Based on the fitness function, you are selecting the individuals. The higher the fitness, the higher the chance of being selected. So, if the fitness factor is good, then that it may be you are selecting as a next. These individuals then reproduce to create one or more offspring, after which the offspring are mutated randomly. This continues until the suitable solution has been found or a certain number of generations have passed depending on the needs of the programmer. So here the programming workflow of it is you are initializing the things when you are assigning the fitness function. Next, then you are selecting the based on the fitness function. Then if you are selected that one, then how it is next it is further exploring the crossover or reproduction of the things. Then mutation is happened. Then if you are reached to the successful solution, then you are stopping. Otherwise, again the same step it is repeating till you are getting the solution. So these are the general algorithm workflows, the initialization and initial population of candidate solution that individuals are randomly generated in that each individual represents a potential solution to the problem and typically encoded as a chromosome, a binary string, nothing but it. That is the initialization. You have started initialization of the individuals. Then fitness evaluation of it is the fitness function. Each individual in the population is evaluated based on how well it solves a problem. A fitness function quantifies the quality of each solution. Then based on the fitness function, the selection process is going on. Individuals with higher fitness are selected to be parents for the next generation. Various selection methods exist, such as roulette wheel selection, that is one of the selection method, or tournament method. The other selection is okay. Like this, any one of the method, either you can select it. The selection process based on the fitness function. The crossover recombination that you have called it. Selected parents exchange genetic material to create offsprings. This involves combining part of parent chromosomes to form a new one, child node, introducing diversity into the population. Common crossover methods include single point crossover or multi point crossover or uniform crossover. There are the various crossover combinations out there. Mutation. So random changes are introduced into the offspring chromosomes. This helps maintain genetic diversity and prevents premature convergence to suboptimal solutions. By exploring new areas of such space, mutation rates are typically low if you are new rate. Replacement, how we are replacing the that one. The new generation of spring replaces the old population based on the fitness point. This can involve replacing the entire population of, or only a portion of it with strategic like generational replacement or steady state generational replacement or steady state replacement. termination, when it is going to terminate this one. If the process of selection or crossover or mutation and a replacement is repeated for a fixed number of generations until the satisfactory solution is found, then you can terminate it. This solution found throughout the process is then presented as the result. Over the every time, every generation, it is showing the results. This is the algorithm. So, how the reproduction, the next step is to generate a second generation. In second generation population of solutions from these selected through genetic operators. Crossover also called as recombination. Here also called as a recombination or mutation also that here also called. For each new solution to be produced, a pair of parent solutions selected for breeding from pool selected previously. By producing the child solution using the above methods of crossover and mutation, a new solution is created, which typically shares many of the characteristics of parents, inherited characteristics. New parents are selected for each child, and the process continues until the new population solutions of appropriate size is generated. Okay, these process ultimately result in the next generation population of chromosomes that is different from the initial generation. The parent generation is different, the child generation is the different group. Generally, the average fitness will have increased by this procedure for the population, since only best organism from the first generation are selected for breeding, along with a small proportion of less fit solutions for regions already mentioned above. Only best breeding only are selected. So this is the crossover, the most common type of single point crossover. In single point crossover, you choose a locus at which you swap the remaining LLS from one parent to the other. This is complex and best understood usually. That is the single point crossover. As you can see, the children take one section of the chromosome from each parent. The point at which the chromosome is broken depends on the randomly selected crossover points. This particular method is called single point crossover in this case because only one crossover point exists. Sometimes only one child or child 2 is created, but oftentimes both offspring are created and put into the new population. The crossover does not always occur. However, sometimes based on the set of probability, no crossover occurs and the parents are copied directly to the new population. So the probability of crossover occurring usually 60 to 70% like this. Then advantage, what are the advantages with the genetic algorithm? So global optimization, that is the one thing we are getting, and flexibility and adaptability, that is another one. It is a flexible algorithm, and robustness to noise. The parallel processing is possible in these cases. All these are the advantages with this genetic algorithm. So what are the other computational costs? Because the computational cost is expensive for this genetic algorithm. That is the drawback for problems with the large population or high number of generations, which can be a limiting factor in time-sensitive applications. Difficulty in defining fitness functions. Based on the fitness factor, if the fitness function is improper, then you may not get the proper result. A poorly defined fitness function can lead to suboptimal or irrelevant solutions you are getting. Lack of guarantee for global optimum, may not get the global optimization. So parameter tuning, it is also a little bit difficult in these cases. These are the drawbacks in genetic algorithm. And coming to the feature selection for text classification, what are the applications means? For sentiment analysis purpose, you can use it. Genetic algorithm feature selection or text classification purpose, you can use it. This one, a text classification purpose, sentiment analysis purpose, and for language modeling purpose, you can use it. Genetic algorithm. Define the parameters language models, select relevant features, and improve model ability. Generate contextually relevant, coherent text using this genetic algorithm. Text summarization purpose also it is useful. J can optimize the text summarization algorithms by selecting a optimal sentences or phrases to include in a summary, thereby enhancing efficiency and the informativeness of the generated summaries. So named entity recognition purpose also you can use it this way. Grammar induction or linguistic analysis purpose. Or these are the some of the examples of the genetic algorithm used in NLP or artificial intelligence. So today's video I covered what is genetic algorithm, what are the characteristics and the key components also I have discussed in this. What are the requirements for the genetic algorithm? The general algorithm flow also I discussed. The reproduction process or crossover process, how it is in genetic algorithm I discussed. And what are the advantages and limitations of genetic algorithm? And what are the various applications of genetic algorithm in artificial intelligence? These are the topics I covered in this video. And if any query, please mail me thrimurthulu.v@mlrit.ac.in. That is mail ID. So my next video I am going to cover A star algorithm and what are the key principles in A star algorithm and algorithm flow. What are the advantages, disadvantages of A star algorithm? One of the example we'll take it in next video, traveling salesman problem, and what are the applications. So thank you one and all.